Guys, this is a recap of what we did in the live session about matter. What is matter? Matter is defined as anything that has mass and volume. The states of matter that I'm going to go over today are solid, liquid, gas, plasma, and Bose-Einstein condensate. I'll go over with the key concepts of states of matter, the composition, classification, properties, changes, and conservation. Let's review your prior knowledge on the states of matter. Each state of matter has particles that are very close to each other and vibrate in fixed position. Solid, liquid, gas, plasma, or Beck. The correct answer is solid. Which state of matter has particles that clumped together? Solid, liquid, gas, plasma, or Beck? The correct answer is Bose-Einstein condensate, or Beck. Solid, liquid, and gas. Which one has the least molecular force of attraction? Is it solid, liquid, gas, plasma, or Beck? The correct answer is gas. Here's a tree map of the states of matter. Solid has particles that are in fixed position. They vibrate in place. They're very close to each other. And solids have definite shape and volume. Liquids have particles that are far from each other. These particles slide past each other and they have definite volume but no definite shape. Particles of gas are very far apart, no definite shape or volume, and these particles are in random motion. The particles of plasma are very far from each other as well. Is an ionized gas. Bose-Einstein condensate has particles that are clumped together. Yes, and they have both the characteristics of a particle and a wave. These were the answers gathered from a live session. Beck stands for Bose-Einstein condensate. Plasma is far compared to Beck. The two scientists involved, Bose and Albert Einstein. Brainstorming questions that were raised during live session. Is powder a solid? Is slime a liquid? Can you freeze a gas? Here are the answers to the brainstorming questions. Is baby powder a solid? Is slime a liquid? Can you freeze a gas? So those were the correct answers. We did a simulation on the states of matter and phase changes. And here are the takeaways from the simulation. The removal or addition of heat changes the phase or state of matter. So therefore, we can say that when heat was added, the molecules moved faster. As heat is removed, the molecules will move slower. Now let's proceed to the second part of the lesson. Classification of matter. Matter could be either pure substance or mixture. Pure substances are elements and compounds. The simplest form of element is an atom, and the simplest form of a compound is a molecule. Solution is classified as homogeneous. Colloid and suspension are classified under heterogeneous mixture. Now let's go deeper into the classification of matter by composition. Pure substance has no variable composition, while mixture has variable composition. Pure substance, all the samples have the same characteristics, while in mixture, different samples have different characteristics. Lastly, pure substance does not change from one sample to another, while mixture's composition may vary from one sample to another. Higher elements and compounds cannot be decomposed into simpler substances by chemical reactions, while compounds can be decomposed into smaller substances. While compounds can be decomposed into smaller substances. Examples of elements are all the elements in the periodic table or man-made, which are naturally occurring or man-made. Examples: we have copper, tellurium, carbon, oxygen, radon, boron, silver. You combine sodium and chlorine, you make a compound of sodium chloride, which is an ionic compound. Water is another example. And then we have octane, which is a combination of 8 atoms of carbon and 18 atoms of hydrogen. Mixture by composition could be homogeneous or heterogeneous. Homogeneous mixture has uniform composition throughout. Heterogeneous mixture has, is a type of mixture that does not have uniform composition throughout uniformly. Examples of homogeneous mixtures are sweet tea, coffee, soda, and lemonade. An alloy is also a solid solution, which is a combination of two or more metals. Examples: we have bronze, brass, and stainless steel. For heterogeneous mixtures, examples are fruit salad, vegetable stew, spaghetti with meatballs, sand and water, and gravel and sand. So, what are your takeaways from the tree map? Compound is made up of different elements. Homogeneous mixture is where you can only see one color. Let's differentiate solution, colloid, and suspension. Particle size: solutions less than 100 nanometers, colloid 1 to 1000 nanometers, suspension 10 to 1000 micrometers. Solution is considered as a homogeneous mixture. Colloid and suspension are both hetero. Particles do not settle. Colloid particles settle by centrifugation. Suspension particles settle by gravity. With the spreading of light, or we call it Tyndall effect, solutions particles do not reflect light, so no Tyndall effect. Colloid shows dispersion of light, so colloid shows Tyndall effect, and suspension varies for Tyndall effect. In terms of filtration, solution can pass through a filter, animal membrane. Colloid pass through filter but not through animal membrane. Suspension do not pass through filter or animal membrane. Here are examples of solutions: sweet tea, soda, lemonade, and saline solution. For colloids, we have fog, we have smoke, milk, and mayonnaise. For suspension, we have muddy water, salad dressing, mixture of flour and water, and mixture of chalk and water. There are many examples in daily life that you can identify, but basically, these are the general characteristics of solution, colloid, and suspension. Now let's differentiate the properties of matter, whether they're physical or chemical. Physical properties of matter are those intensive or extensive characteristics, while chemical, we're referring to how a substance interacts with other types of materials. Examples of physical properties are states of matters like solid, liquid, gas, plasma, Bose-Einstein condensate. Other examples are viscosity, density, specific heat capacity, freezing point, boiling point, melting point, magnetism, volume, hardness, mass, solubility, compressibility, luster, brittleness, ductility, malleability, and conductivity. For chemical properties, we have reactivity with air, acid, bases, water, and others, flammability, heat of combustion, enthalpy of formation, ability to oxidize, chemical stability, toxicity, and possible chemical bonds. Those are properties of matter that we're going to discuss further as we go through the unit in chemistry. Different kinds of changes. We have physical and chemical. When we say physical change, those are the changes in substances' physical properties, such as breaking, stretching, cutting, tearing, shattering, grinding, and mixing. So phase changes basically are just considered as physical. Substances are melted, frozen, boiled, condensed, sublimated, or deposited. Chemical change causes a substance to change into a new substance. So there's a production of a new substance. During the chemical reaction, there's always a new chemical formula for the product of the reactants. And here are the examples of chemical change: rotten, burning, cooking, and rusting, bubble formation, color change, and release of other. So the last but not the least, we have an overview of the law of conservation of matter. Matter cannot be created or destroyed. It can only be transformed from one form into another. Chemical reaction, mass is conserved and energy is conserved. We're going to do more activities in Canvas and quizzes and Jamboard. This goes to Edpuzzle, PhET, Educate Learning, and Person Education Incorporated. Thank you so much.